Hey guys, so today we're going to be talking about the enzyme-linked immunoabsorbent assay, also known as ELISA. And what this is it's a process by which we can determine the presence of antigens or antibodies through the use of fluorescent enzymes. There are two methods that we're going to look at today, direct and indirect ELISA. So let's start out with direct ELISA. It starts with the primary antibody here, and what happens is this, along with a fluorescent enzyme, which is shown here, the fluorescent enzyme is going to bind to the primary antibody, and then this structure is going to find the target antigen present in the solution, which is shown here. And once this binds to the target antigen, fluorescence will take place, and we can observe this qualitatively through color change. So that's direct ELISA. Another method is indirect ELISA, and you're going to have the same primary antibody, but also you're going to have a secondary antibody shown here. And the secondary antibody is actually what the enzyme is going to bind to this time. So this carries the enzyme to the primary antibody and forms this conjugated structure. This conjugated structure will then bind to the target antigen, and then just like in direct ELISA, fluorescence will occur, and we can observe this through color change. And this type of diagnostic method is really useful in determining the source of an infection, which can be seen here in these samples taken from 6 individuals labeled A through F. And the cuvettes containing a dark blue solution are positive for the presence of infectious antigens in this case. The cuvettes that with a pale blue solution remain uninfected. And these equations that you're seeing show an exchange of bodily fluids between the individuals, so we can track who interacted with who. From here we can eliminate individual B, as they obviously don't carry the antigen because no fluorescence is being observed. Individuals A and D can also be eliminated as they did not infect individual B, so they must have obtained the infection from another individual. Because we know that A and B did not initially carry the antigen, we can trace the infection to individuals E and F, and the common individual with these two is C. So we can conclude that individual C is patient 0 for this infection.